Hi, Assalamualaikum. Guys, are you ready? Okay, so let's continue our activity, which is under Leptons and Meka, right, which is under Physics unit. Alright, so for today, we are going to discuss about chapter 6, where the topic is the alternating current. Alright, so for today's activity, we are trying to learn how to understand the question and how to use the equation in solving all the question given here. Alright, so I think maybe by discussing one or two or maybe three questions, then you will understand very, very well this chapter. Okay, so let's start by question number 1. Are you ready? Okay, so what is the question? Okay, let's say by giving you a question to be like this. Okay, a capacitor of 1500 microfarad is connected to 2.5 volt and 0.45 amperes lamp and a 60 hertz supply in series. Calculate the RMS voltage supplied to the lamp and the voltage across the capacitor. Okay, first of all, we need to know what info do we have here, okay, according to all the values given just now. Okay, so we just start by the first info given here, which is 1500 microfarad. What is that? That is capacitance of capacitor, which is C. Okay, connected to 2.5 volt and 0.45 amperes lamp. Okay, so this is the voltage across the lamp. That one is VR, okay? Because as we know, according to any lamp, the energy released by the filament, isn't it? It becomes hotter and hotter, isn't it? Caused by the resistance, actually. So for any lamp, we just assume it as a resistor, lah. Okay? So this is VR, V across the lamp. And this is the current through the lamp. That one is I RMS. Okay? And the info given here is our frequency F in series. Okay, what does it mean? So not basically everything just arranged in series. Okay, what do we have? Just a capacitor connected to a bulb. Okay, and then connected to the power supply, which is our AC. So this is the situation where the voltage given now is V across the lamp. That one is VR. Okay. Also the current through the lamp, that one is I RMS here. Alright. So remember, the capacitor and lamp now, they are arranged in series. So the current through the capacitor is still the same, which is equal to I given here, and which is I RMS, because they are arranged in series. Okay, so now they ask you to find the RMS voltage supplied to the lamp. So they ask you to find VRMS. Okay, how do you find VRMS? Okay, so basically we need to know what is the equation. Okay, by having R, this is our R and C. Okay, according to the phasor diagram, seems like this is VR. It just lay on the X component. And this is VC, which is on the Y component and directed downward. Remember, charging is below the rumput, isn't it? So this is rumput, below the rumput is charging, and above the rumput is lembu, isn't it? So there is no lembu. What do we have? Just rumput and charging, isn't it? Alright, so this is the phasor diagram. So they ask you to find V, RMS, this V. Okay. So by using the triangle, remember V equal to VR squared plus VC squared and square root, isn't it? So to calculate VRMS, we need to calculate, okay, VR given already here, but VC is not given, isn't it? So we need to calculate VC lah. To calculate VC, we need to know the value of XC. Why? Because VC equals to I XC, isn't it? So what is XC? XC is the capacitive reactance. Okay. So we need to calculate XC first lah. Alright, so let's start our calculation by calculating the capacitive reactance first. So XC equals to 1 over 2 pi FC. So F given is 60 Hertz and capacitance given now is 1500 micro. Okay, substitute into the equation and then you will get XC, which is equal to 1.77 ohms. Alright, by getting XC, and then we just calculate VC, where VC equals to I RMS XC. And remember, I RMS actually given already. Why? Because they are arranged in series, so the current should be the same, isn't it? So I RMS through the bulb or lamp now still equals to the current through the capacitor. Okay, so I RMS equal to 0.45, while XC calculated just now is 1.77. Substitute into the equation so that you will get VC equals to 0.79. By getting VC, by knowing VR, then we may calculate V using the resultant equation, isn't it? Where V RMS equals to square root of VR squared plus VC squared. VR given already, which is equals to 2.5, and VC calculated just now equals to 0.79. So substitute into this equation so that you will get the answers directly equals to 2.62 volt. Okay, next for the second question, they ask you to calculate the voltage across the capacitor. So they ask you to find VC here. So what is VC? Okay, actually we have calculated just now. Okay, to calculate VC, we need to calculate XC first, isn't it? So for this question, you don't have to calculate again. You may state as like this lah, as in 1, or maybe we just show the calculation again. It's okay because it's not too long, isn't it? It's quite short. So in answering the question, okay, we just show the calculation again lah, for safety, yeah. Alright, so we just calculate XC, alright, and then you will get VC. Or XC calculated already, so we just show the calculation. Okay, we just show the calculation of VC, which is VC equal to I RMS XC. So substitute the XC calculated in the first part before the current given already, then you will get VC, which is equal to 0.79 volt. Okay, settle question number 1. Okay, let's go through with the next question, which is question number 2. Okay, let's say by giving you a question to be like this. Okay, so in RLC circuit, a 2.5 microfarad capacitor is connected to a 10.5 Henry inductor and 50 ohm resistor. So we are talking about the capacitor, inductor and resistor. That one is under RLC circuit lah. We have 3 components, which is capacitor, inductor and resistor. Okay, so calculate the resonant frequency of the circuit. If the inductance and capacitance of the circuit were each triple, what is the new resonant frequency? Okay, so now we have 2 different situations. First, they ask you to calculate the resonant frequency for this case, and then by increasing the inductance and capacitance to be triple, what happened to the resonant frequency? What is the new resonant frequency? Okay, we have 2 different resonant frequency. Okay, for something like this, I like to label the first resonant frequency as F1 lah, and then for the new resonant frequency as F2. So we may differentiate the frequency. Okay, again, we need to label all the info given. Okay, first what do we have? This is the capacitance of capacitor, and this is the inductance, okay, of inductor, and this is the resistance of resistor. Okay, so they ask you to calculate the resonant frequency, which is F1, also the resonant frequency, the new resonant frequency, which is F2. Okay, so again, how was the circuit? What do we have? Just a capacitor connected to an inductor, connected to a resistor, and then connected to the power supply. So this is the situation now, which is C, L and R. Okay, so first, how to calculate the resonant frequency? Okay, I think you know what is the equation, isn't it? So the equation of resonant frequency is F resonant equals to 1 over 2 pi square root of LC. And here, as I told you before, okay, we just assume that the first frequency as F1. Okay, because we have two different frequency. Alright, so we need to compare it now. Okay, so F1 equal to 1 over 2 pi square root of LC. So L is given, C also given. Substitute into this equation, then you will get the resonant frequency directly, which is equals to 31.06 Hertz. And it's quite easy. Now for the second situation, by increasing the capacitance and inductance to be triple each. Okay, so what is the new resonant frequency? Okay, how do we answer the question? Okay, all right, so this is the question. So by increasing the capacitance and inductance to be triple, okay, what will happen to the new resonant frequency? Okay, so now by using the same equation as before, resonant frequency equals to 1 over 2 pi square root of LC, but now L and C become triple. So mathematically, you may get this. Okay, so 3 times 3 giving you 3 squared. 3 squared and square root giving you 3. Okay, 3 times 2 pi and then square root of LC. So here 1 over 2 pi square root of LC still equals to F1. Okay, this is F1 actually. Okay, so 1 over 3 times F1. F1 calculated just now, which is equals to 31.06 Hertz, isn't it? And then multiplied by 1 over 3. Okay, so that you will get the new frequency now become 10.35 Hertz. Alright, seems like we are using a ratio method now. Okay, alright, so as conclusion, we may say that by increasing the inductance and capacitance, we have decreased the frequency. Okay, alright, next question. Alright, so question number 3. Okay, what do we have now? Okay, read the question first. In an AC circuit, the supply voltage is given by, alright, so this is the equation of voltage, alright, which is V equals to 240 sine 5000 T plus pi over 2, where V in volt and the current is given by, so this is the current equation, which is current equals to 0.480 sine 5000 T, where current now I in ampere and T in second. So what is meant by root mean square RMS value of current? Okay, first question. All right. Okay, first of all, they ask you to explain the meaning of root mean square RMS value of current. Okay, it's quite simple, given already in your notes. So what is RMS current? So RMS current is the effective value of AC or alternating current, which produce the same as power or mean or average power as produced by the steady direct current or DC when the current passes through the same resistor. Okay, seems like this is our effective current actually. Effective AC, giving you same power as DC. This is the keyword. Okay, because as we know, under alternating current, the current always change with time, isn't it? So we don't have any constant current. So this is our effective current lah, giving you the same effect as our steady current in DC. Okay, all right, for the next question, they ask you to calculate the impedance. Calculate the impedance of the circuit. So by giving you an equation of voltage and current, now they ask you to calculate the impedance. So how do we answer the question? Okay, so from the equation, which is v, okay, before that, generally we know that the equation of v here is equals to v equals to v naught sine omega t plus phi, isn't it? And for I equation, I equals to I naught sine omega t. So this is phi, this is omega, this is v naught. Okay, and for the current equation, this is I naught and this is omega. So basically they ask you to calculate the impedance now. So what is the equation of impedance? Remember, V equals to I Z. So by giving you V naught and I naught, we are talking about V naught equals to I naught Z. So how do you calculate Z? Z equals to V naught over I. So by using the equation of Z impedance equals to V naught over I naught, V naught given already, which is equals to 240, while I naught given is 0.480 amperes. Substitute into this equation so that you will get the impedance equals to 500 ohms. Okay, so this is the way how do we calculate the impedance. Okay, for the third question, and still the same, we are talking about question number 3, but for the third question, they ask you to calculate. Okay, let's check what is the question. Where is it? They ask you to sketch the phasor diagram for V and I and state the electrical component, either RCL, RC, or RL. This one should be O, or RL. Okay, which circuit is that? Is it under RCL? Is it under RC or RL? Okay, give your reason. Okay, so how do we answer this question? Okay, again, first, please check the equation given just now. The equation given for V is V equals to 240 sine omega t plus phi. So the graph is not purely sine actually, because sine here with phi. So phi is the initial phase angle. So we are talking about shifted graph. So the graph is not purely sine, okay? Compared to the current, where the equation given out is I equals to I naught sine omega t. So there is no phi. The equation is really in sine or purely sine. But for V is not in purely sine. So I think you have learned before in chapter 9, semester 1, under simple harmonic motion. How do we convert the equation? For some shifted graph under sine, it still equals to cos. Can you remember that? Okay. So for this, alright. So V equals to V naught sine omega t plus phi still equals to V naught cos omega t. Remember, we have learned this in chapter 9 in semester 1. Okay, so the graph actually in purely cos. Okay, what does it mean? Okay, so we just convert the equation given now to be in cos. So that the equation given now is V equals to 240 sine 5000 t plus pi over 2 still equals to V naught is 240 and then cos omega is 5000 t. So this is the equation of V, which is in purely cos. And then the current given for I is really in sine or purely sine, so that the equation still the same. So I equals to I naught, which is 0.48 sine omega t. Alright, so as we know, for any purely sine equation, it's really lay on the x component, while for cos graph or cos equation, seems like it just lay on the y component, isn't it? So basically the phasor diagram just be like this. For the current, it's really on the x component, okay, because the equation is purely sine. And for the voltage, it's really on the y component because it's purely cos. Okay, so this is the phasor diagram. So according to this situation, as we know, the rotation of phasor diagram just in anti-clockwise, isn't it? So in this case, we know that VL leads the current by 90 degrees or pi over 2 radian. Okay, V leads the current. So according to the situation, as conclusion, V leads the current by pi over 2. Thus, this is pure inductor circuit. Pure inductor circuit should be RL circuit. Okay. Okay, maybe some of you still confused. How do you get this? Okay, let me remind you again how do you get this. Let's recall back what do you have done before in semester 1 in chapter 9. Okay, so V cos omega t. Let's say the equation of cos graph just be like this. Okay, so this is our cos graph, isn't it? And to be like this. Okay, so now to get sine graph, okay, sine graph just be like this. So to have this graph, we need to move the axis, the y-axis here to be here. Am I correct? So we need to move the axis to the left. By how many? By this amount, isn't it? So to the left is positive, and then by this amount is pi over 2. So positive pi over 2. That is why you will get this pi over 2 positive. Okay, so actually the graph is purely cos. That is why from this equation we just convert it to be in purely cos equation. Okay, by shifting and the axis to the left by this amount. To the left is negative, positive, and then by this amount, which is quarter of lambda here, that one is pi over 2. Okay, all right, next for question 4, still the same. According to this question, question number 4 asks you to calculate, okay, what value is that? Okay, so now they ask you to calculate the instantaneous and maximum power dissipated in the circuit. So again, by giving you the equation of V and I before, as before, then they ask you to calculate the instantaneous power, also the maximum power dissipated in the circuit. Okay, so how to answer this question? Okay, as we know, the instantaneous power equation is P instantaneous equals to I instantaneous multiplied by V instantaneous. So I instantaneous equals to I naught sine omega t, and V instantaneous equals to V naught cos omega t. Okay, so instantaneous current and voltage now depends on t lah. Okay, so mathematically by having these two equations, okay, using trigonometry, you will get I naught V naught, and then sine omega t multiplied by cos omega t, giving you sine 2 omega t, so that you will get this. Okay, so I naught and V naught, and sine omega t multiplied cos omega t, you will get this, which is half sine 2 omega t. Okay, mathematically you will get this. So we just substitute all the values of I naught, V naught, also omega. I naught again given here, V naught also given, and then this is omega. Omega equals to 5,000 times 2, giving you 10,000. So substitute into the equation to be like this, and then okay, this is our instantaneous power in term of t. Okay, so instantaneous power the value are different at different time, isn't it? So that is why the instantaneous power now just in term of t. And then they ask you to calculate the maximum power. So for the maximum power, the cosinus function here just equals to 1, which is maximum, because for any sine or cos, the values just between 0 until 1. So by asking you to calculate the maximum power, the value should be maximum, which is equals to 1. Okay, So based on that, the maximum power sine 10,000 t equals to 1, so that, okay, P instantaneous maximum now equals to 0.48 times 240 times half, where this value is equals to 1, giving you 57.6 watts. All right, so this is the way how do we answer question number 3. Easy, isn't it? That is why we call it physics is fun. Okay, next question, okay, which is our last question, question number 4. What do we have now? Okay, read the question first. A resistor of 6 ohms, a capacitor of 3000 microfarad, and an inductor of 5 millihenry are connected in series. Okay, basically they are arranged in series. Okay, if an AC source of 50 Hz and peak voltage of 240 volt is connected to this circuit combination, calculate the total impedance of the circuit. Okay, as usual, we need to identify what info given here. Okay, first, this is our R, which is 6 ohm, and 3000 microfarad is our capacitance, and 5 millihenry is our inductance. And remember, this is C and L. It's not XC and XL. XC should be in ohms. XL also in ohms. So to know what values is that, please refer to the unit. Ohm is resistance, microfarad is capacitance, millihenry is inductance. Okay, by giving you 10 ohms, that one is reactive, inductive reactance. Okay, by giving you, let's say, 40 ohms here, that one is XC lah, which is capacitive reactance. Okay, but now the unit is microfarad, should be capacitance, Henry is inductance. Okay, this is the way lah. Please check the unit. Okay, and then if an AC source, okay, this is our frequency, and frequency is given, and peak voltage. Okay, peak voltage is V naught. Okay, it's not VRMS, V naught, because the keyword now is peak. So remember, by giving you peak or maximum voltage, that one is V naught. Okay, other than that, that one is VRMS. Okay, so they ask you to calculate the total impedance of the circuit. Okay, how to calculate the total impedance? So remember, the equation is impedance equals to square root of R squared plus XL minus XC squared, isn't it? Sorry, squared and square root here. So to calculate impedance, we need to know R given already. XL is not given. What do we have? Just L only. Also XC is not given here, isn't it? What do we have? Just C. So that we need to calculate XL and XC. Okay, so as usual, we just start the calculation by calculating XC first. So XC equals to 1 over omega C, where omega equals to 2 pi F. So substitute the frequency, also capacitance given now, which is in micro. Micro equals to 10 to the power negative 6, giving you XC equals to 1.06 ohm. See, by having ohm, that one is XC, and microfarad is C. All right, then we just calculate XL. XL equals to omega L, where omega equals to 2 pi F, isn't it? Okay, so again substitute F, also inductance, which is 5 millihenry. Milli is 10 to the power negative 3, so that you will get XL equals to 1.57 ohms. Okay, by getting XC and XL, by knowing R, we may calculate impedance using this equation directly, isn't it? So the impedance equals to square root of R squared minus XL minus XC squared. Oh, sorry, this one is not minus, it should be plus. Plus XL minus XC squared. Okay, so again, this one also plus. Okay, so substitute R equal to 6, XL equals to 1.57, XC equals to 1.06, so that you will get the answers, which is equals to 6.02 ohms. All right, so this is the total impedance, okay, for this situation. Okay, next, from the same equation, now they ask you to calculate something new. Okay, what is the question for the second part? Okay, so based on the same question, now they ask you to calculate the resonant frequency of the circuit and explain the power factor during the resonance. Alright, so I think it's quite easy. By using the equation of resonant frequency directly, resonant frequency equals to 1 over 2 pi square root of LC, isn't it? L given already, also C. So this is our C and this is our L. Substitute into this equation so that you will get the resonant frequency equals to 41.09 Hertz. Alright, and then explain the power factor during the resonance. Okay, so remember, at resonance, XL equals to XC. So according to the situation, as we know, impedance Z equals to square root of R squared plus XL minus XC squared and square root, isn't it? So when XL equal to XC, they are cancelling each other, giving you 0 here. So what happened now? Square root of R squared equals to R, isn't it? So Z equals to R. And according to the phasor diagram before, for the phasor diagram, what do we have? So this is R, which is rumput, isn't it? And then this is our XL, which is lembu, and below here is XC. But now XC and XL just lay on the Y component, so we may calculate the resultant. Bring XC to the upper side here, become minus lah, minus XC. No more XC here. So XL minus XC and R. So remember, this is our Z, which is the impedance, isn't it? So based on that, by using the triangle, by having a triangle where this is Z, this is XL minus XC, sorry, XL minus XC, and this is R. Okay, this is the angle, phase angle. Okay, so remember, power factor equals to cos phi. So power factor is cos phi. So according to this diagram, cos phi equals to, cos is, okay, this is opposite, adjacent and hypotenuse. So cos phi equal to adjacent over hypotenuse, isn't it? So which is R over Z. So in this case, Z equals to R. So Z equal to R, giving you R over Z equal to R. R over R equals to 1. So in this case, the answer just be like this lah. So during the resonance, Z equals to R, so that the power factor is 1. Okay, it's too short, isn't it? So this is the way how do we show or explain the answer. Okay, so at resonance again, XL equal to XC, so the XL and XC cancelling each other, giving you Z equals to R. When Z equals to R, according to the phasor diagram, so sorry, this one impedance diagram, according to the impedance diagrams, we just take out the triangle. So power factor is cos phi, so cos phi is R over Z. So at this time, Z equal to R, substitute here, and then R divided by R, giving you 1. So the power factor is 1. Okay, see, I think it's quite simple actually for chapter 6. We need to understand, okay, what info do we have, and then how do we choose the equation, the suitable equation, in answering the question. Okay, so that's all I think for chapter 6. Maybe after this you may try to answer all the past year's question. I think we don't have any problem for this chapter. It's quite easy. Okay, I think that's all. Thank you.